Good morning. This is my presentation, Global Perspective, Seismic Hazard in Latin America Proposal for Urban Planning. This lecture consists in three parts. The first part, I will show some maps with seismic hazard in different countries of Latin America. The second part, I will present my proposal for different risks with solutions, mainly in Colombia. The third part, I will show 11 points for the discussion in this event with my proposals. This is my city, Bogota. Bogota is in 2,600 meters above sea level. The population is 8 million people. In these presentations, I will show different slides about my country. When it appears, I will change the topic or standard. The seismic code of Costa Rica is the version 2010. They have three seismic hazard zones. In red color is the high seismic zone, and in the green color is the low seismic zone. The different zones, Costa Rica, there are 4 typology of soils. The first soil it's rigid soil and rock. The second is dense soil, intermediate soil. The third soil is the 6 meters between 12 meters soft clay or 6 meters no cohesive soils, and the fourth soils up 12 meters soft clay. With these classifications, the peak acceleration, seismic acceleration for design is between 0.20 and 0.44 G accelerations. This is the seismic high level and the low seismic level for Costa Rica. In this slide, you can see the Caribbean coast. This is in the north of Colombian north. Argentina has a standard INPRED Shock 103 building seismic code. Argentinian Interior Ministry is the authority of this code. The version is of July 2018. They have 5 zones, seismic hazard zones. The border of Argentina are Chile in the east, in the north Bolivia, Paraguay, Brazil, and Uruguay. In the green color is the low seismic hazard zones. In blue color is the intermediate seismic hazard zones, and with the yellow and red color are the high seismic hazard zones. The accelerations of these hazard zones in low seismic are 0.05 G to 0.10 G. In the case of intermediate seismic hazard, the acceleration is 0.18 G. And finally, for the high seismic hazard, the accelerations varies between 0.25 G to 35 G. This accelerations is near to Chile in the center of this country. Respect of soils, typology of soils of Argentina, they have 5 typology of soils. The first corresponds to SA, strong rock, with wave velocity higher 1,500 meters per second. The second typology, SB, rock, with velocity between 760 to 1,500 meters per second. The third class is SZ, dense sand soft rocks with wave velocity between 360 to 760 meters per second. The fourth typology is the cohesive soil and low plasticity with wave speed between 180 to 360 meters per second. At final, SE, soft soil and high plasticity with wave speed less 180 meters per second. This is the way to jungle, Colombian jungle, the Amazon region. Here we were in 2,000 meters above sea level. This place, the name is Putumayo, near to the border of Ecuador. The Colombian Seismic Code, NSR10, Norma Sismoresistente Colombiana del 2010. This is the map of Colombia. Here is Venezuela, here Brazil, here Peru, here Ecuador, and here Panama. When the Andes mountain range entered to Colombia, these hills divide in 3 mountain range. The first, the West Hills, enter to Panama. The East Hills enter to Venezuela, and in the middle is the Central mountain range, and these hills finish here. Bogota is here in the middle of Colombia. We have 3 zones. The red color is high seismic hazard, the yellow is intermediate seismic hazard, and the green color is the low seismic hazard. Here is the Pacific Ocean, here is the Atlantic Ocean. The typology in Colombia of soils, we have 6 typologies. The strong soil or rock is in the typology A, the type B. All the typologies depend of the wave speed. If the wave speed is between 760 to 1,500 meters per second, is typology B. Typology C corresponds to soft rock or dense soil. Typology D is rigid soils. Typology E corresponds to 3 meters of clays. And finally, the type F corresponds to organic clays, sensitive clays, high plasticity clays, and or 36 meters of clays. We have 2 maps. The first maps is the horizontal accelerations with 10 zones. Uh, the values of the accelerations between 0.005 to 0.50 for the horizontal accelerations, and the vertical accelerations varies to 0.05 and 0.50. We have seismic microsonification. This is the map of Bogota. We have different classifications of the soils, but these classifications, this classification depends to the wave speed. We have piedmont, lacustrine, hills, alluvial lake, alluvial, and hillside deposit. The accelerations in Bogota oscillates to 0.14 to 0.26. Here in the blue color is the east and this mountains range. This is my country in the east, near to 1,000 meters above sea level. The name in Spanish of this sitio is Cañón de Chicamocha. In this presentation, I have tried about the seismic risks, but is applicable to all the risks. At final, I will present my conclusions. First, proposal. Second, development educational material, interchange other engineers, formative processes with the students, and one is about conclusions. In this link, you can download the paper. This paper is from 2005, because we have in Colombia problems with the equations to design the neoprene bearings, and this equation subestimates the actions. Then this is a proposal to change these equations. Finally, this equation was included in our Colombian code bridges design. In this paper, you can see lessons from the April 2016 Ecuador earthquake with the format of inspection with ATC in Ecuador. In this paper, you can read comparative analysis of the behavior of apprentice engineers and postgraduate engineers in front to the post-earthquake assessment format of Bogota, because we have problems, at my viewpoint, with this format, because the engineers don't have any education in this format. They had problems collecting the information, and occur mistakes in the investment to reparation of the constructions. This is another paper with other proposal to new structural design normative for truss bridges for public networks in the Colombian cities, because we have problems with the spectrum, seismic spectrum to design. It's not clear here in Colombia what spectrum I need to use to design. This is other proposal for me for peer reviewer guidelines for a structure with supplemental damping and seismic isolations because in this moment we had worked in the first edition to standards to design isolation and dissipation devices, but it is not clear for the supervisor, technical supervisor, how to receive these devices. This is other proposal for me. In this moment, I have 14 ebooks about different topics in structural engineering. For example, this is the vibrating machine foundations design, others in steel structural design, others in cold form design, and in water design too. Beam methodology too. This is a prosthetic structures for beginners. Interchanges with the colleagues are more important for the advances of the society. Interchanges with in the formative processes with the students. This is my students in the university. And conclusion, for me, it's necessary to first educational material accessible for engineers and the population. Second, consensus seismic design spectrum. 3, use of material according to region. 4, update seismic design standard each 5 years. 5, adaptation international standards if it is required in the region. 6, introduction new technologies in construction, design, or facilities when the region requires it. 7, adaptation to the climate change. 8, structural resilience. 9, worldwide collaboration on climate change adaptations. 10, government investment in climate change adaptation projects and studies. 11, development manuals for the population to prevent risks and disasters associated with the climate change. I want to say thank you, acknowledgement for this invitation, the Tehran Province Construction Engineering Organizations, especially Engineer Mehdi Moharami Sham Ashby, Engineer Guillermo Reyes from Cuba, Engineer Mirko Cuellar from Bolivia, Engineer Francisco Restrepo from Colombia. And thank you for these invitations. I'm very happy to express my ideas and my proposal in this event. Thank you very much.